Hello, Precalculus students. This is lesson 54, well, at least the first half of it. And our goal for today is just to understand the basic trigonometric identities. And identity is just kind of that, like your identity is who you are. And you might change clothes, you might change your hairstyle, you might even change your makeup or get plastic surgery, but you're still you. So you might change the way you look, but it's still the same thing. So this first part is really just a review. If you have a triangle like this, a right triangle, and this angle down here is x, this side over here is the opposite, this side up here is the hypotenuse, and this side over here is the adjacent. And so you're just going to go through and write these trigonometric ratios. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, and you can finish these on out. Like secant is the reciprocal of the cosine, so this is going to be the hypotenuse over the adjacent. Okay, and you can go and just finish filling those in. Alright, now this one might be a little bit new, but hopefully it'll make a little bit of sense. Think about the first quadrant here, and if I were to draw a triangle, and this angle, I probably should have used like theta or something like that. And call this length the hypotenuse of 1. Now this point right up here is some y distance off of the x-axis. And this point right here is some x distance away from the y-axis. So this point right here, for any angle, is going to be x comma y. Okay, that's where we get the unit circle. So remember, the sine is opposite over the hypotenuse, in this case, which is 1. So I would say this would be length y, this is length y, and this length down here is x. And the hypotenuse in this case is 1. So really you don't need to say y over 1, you can just say this is equal to y. Cosine would be x over 1, which is just x. And then tangent is equal to opposite over adjacent, so this would be y over x. And then those other three would just be the reciprocals, so like cosecant here would be 1 over y. And you could, okay, I've done like 4 of the 6, so you can do that now. So now it says complete the reciprocal identity. The reciprocal identity is just saying, getting the idea of here is like, this is the same thing as 1 over cosecant of x. And this is the same thing as 1 over sine of x. And that's true, the same pattern holds true for all of those. And that will come in handy tomorrow when we're working with those. And you can kind of use the idea of x's and y's and things like that to help you with that if you want. And then this next one, I really just want to point you to this. Notice tangent is equal to y over x. Now notice, what is y equal to? What is x equal to? So then I could say tangent is equal to sine of x over cosine of x. And cotangent then of course would be the reciprocal of that. Alright, now these are explained in depth more in the book, but I also wanted to point out here that this is like pi over 2 if we're talking in radians. So anytime you see that 90 degrees, don't freak out. It's also the same thing as pi over 2. Either one of those are the same. So we know that a sine function, sine of 0 is 0, and then it peaks out over here at pi over 2, or 90 degrees. Then at 180 it's back 0. At 3 pi over 2 it's down here at negative 1, right? So this is what the sine curve looks like. This one is sine of x. Now, think about what if I said sine of 90 minus x. Well, that is just going to be a shift to the left. So think about, instead of being at the origin, it's going to be over here at negative 90 or negative pi over 2. Instead of being at the peak at pi over 2, it's going to be the peak right here. So these are going to be moved like this. And so now if you graph this, you're getting something that looks pretty familiar. In fact, that red line is exactly cosine of x. So this sine of 90 minus x is the same thing as cosine of x. And same idea here with cosine. It's the same thing as sine of x. If you shift it 90 degrees left or right, actually, it would, that's not true. If you shift it 90 degrees left, you'd end up with the same thing. It's called a phase shift, which reminds me of a funny joke I'll have to show you later. So you can kind of fill out the rest of this there from your book. It's on page 275. Now, to complete each parity identity or even or odd functions, I'm not sure if you talked about those before. If not, you will later. But just grab a unit circle and for a second just look at sine of 30 degrees and then look at sine of negative 30 degrees. What's the difference between those two? Well, just a sign change. So what that's saying is if you moved, because this negative x is saying that you're going to move in the negative direction, right? You're going to move down versus moving up. So the only thing that changes is just the sign of that. So I could pretend this moves up 30 and then just take the opposite of that. So that means this would come out to be just negative sine of x. So that how I can kind of pull that, instead of inside, I've used it outside. Now if you do something similar with cosine, if you go in and look at cosine, if you go up 30 degrees and down 30 degrees, you end up with actually just the exact same number. That's because it's what we call an even function. I'm not going to get into depth with that because it's a whole lesson in itself. But the fact is that this is just the same thing as cosine of x. So you can just kind of take that out. It doesn't matter if you're moving in the positive direction or the negative direction, you end up with the same value. Okay? And again, this is on page 274, so you can finish filling that in. The last thing there, I guess, is those three things. So you should know these and know everything we've talked about thus far. Have this filled out so you can use it on your homework tomorrow. So you need to have it filled out completely when you come to class tomorrow, because you're going to need to be using this to reference as you do your homework tomorrow. These is on page 276. So finish filling this out, bring it tomorrow so you can do your next homework.